Hello, everyone. My name is Josh Furman. Welcome once again to the third System Design Roundtable from Meyer Sound. This is called Spacemap Go System Design, Designing Practically for Different Rooms. Before we begin, I want to introduce my primary roundtable panelists with me. We have Mr. Bob McCarthy, Director of System Optimization. Then we have Yanina Canales, application architect, spatial audio specialist, and one of the product developers of Spacemap Go. We also have Jose Gaudin, technical support specialist, and Jose is also one of the product developers and managers of Spacemap Go. And my name is Josh Furman. I'm also technical support specialist. And so today we're going to first review how to deal with fills and subsystems within Spacemap Go. And then we're going to continue our conversation about using Bob McCarthy's guidelines for design and scaling them to different rooms. And then in the middle of all of this, while we're talking about these different room examples, we're going to talk about designing practically. We're going to have to be making compromises. Bob and I and all of us will just talk about where we can consider making cuts to things and how we can adapt and design a system with a given loudspeaker inventory or a given budget. So to begin, let's talk about fills and how to deal with them within the application before we get into the system design side. So there's a couple useful type of nodes within Spacemap Go that we can use to make our space maps utilize fill systems. The first is a virtual node. And a virtual node is a jack of all trades, multi-purpose node. The first purpose of a virtual node, as we've said, is to just be the third point in our triangular panning surface, or triset. The second purpose of a virtual node is that it provides weighted distribution of audio level to speaker nodes that it is linked to. So in the example you see in the bottom left, we have a virtual node that is linked to two speaker nodes. And we notice that the location of my position locator, that the matrix level of both of these outputs is the same. So if we had 4 loudspeakers and one virtual node, and these 4 speaker nodes were linked to this virtual node, what the virtual node would do is divide the audio level or power to all 4 of these speakers connected. So each speaker would get 25% of the overall audio level. So if I'm sending 85 dB from my console, that 85 dB gets equally powered amongst those 4 speakers so that we have 85 dB in the room and not extra summation as you would expect. In addition, we have another tool called a derived node. And unlike a virtual node, a derived node derives its audio signal from what speaker nodes are connected to it. So if I have a left and right speaker node and I have one subwoofer, I can link my 2 speaker nodes to the one derived node and make that derived node output the subwoofer. So this is similar to an aux send on a mix console in that I can have a whole bunch of things and send it down one pipe to one speaker. So this is a great way to deal with subsystems and fills. Here is a room, and what we have is a main left and a main right loudspeaker. And if I wanted to, in Spacemap Go, I can make a space map that is a main left speaker and a main right speaker. You can see the matrix level here for both speakers. And I can use Spacemap Go, the application, with 2 speakers and make a stereo panner. And I've added silent nodes down below here and here. And this allows me to have level on the y-axis and pan on the x-axis. So that might be useful if I had only 2 speakers in my budget. Well, what if I could afford a little bit more and I was able to get 2 more loudspeakers in my room? Well, using the free Spacemap Go application, I could simply just add those 2 speakers, plug them into my Galaxy, and now with a new space map that I just drew, I can now use this space map as a quad panner to my 4 speakers in the room. Main left, main right, and rear left. So there is now a quad panner within Spacemap Go. Well, while we were talking, an architect decided to build a balcony in this room. And so now this complicates things because the physical obstruction of this balcony is preventing my rear speakers to get to my orchestra audience. So I'm going to need some fill systems. The first type of fill system I'm going to need is to make sure that my rear speakers get back to the orchestra. I will just have a couple lip fills on the balcony to make sure that our rear surrounds are still arriving here. The next type of fill system I need is for the upper balcony, because these speakers can't reach all the way up here. So I'm going to need a couple delay fills, and then I'll have a couple rear surround fills as well to make sure that the people upstairs also get a rear surround effect. And then because this balcony is so steep, my mains can't reach all the way over here. So I need a couple under balcony fills for my main left and right. So now, in order to maintain that quad panner that I built, I need to connect some more speakers. And there's a couple ways to do that. The first way is using a virtual node. And we have a virtual node here. We have 4 virtual nodes to replicate our 4 corners of the room. And what we simply did was added each loudspeaker node and connected the corresponding speaker to each virtual node. And now with this, I can manipulate every speaker in the room and have weighted power distribution amongst every speaker. I also linked every speaker to the center, so if I need to have sound evenly distribute throughout every speaker in the room, and we can see across the matrix level that every output in the galaxy has the exact same level. So that's one way to do it, using virtual nodes and linking speaker nodes to it. One important note is that the trisets that I made for this are not connected to the speaker nodes. The trisets are connected to only the virtual nodes, and the speaker nodes are linked to the virtual node. To show you what that looks like, we will go into the space map I created. And if we look at a triset and we just select one, we can see that the triset is connected here, here, and here to the virtual nodes. And then we can see that each one of our virtual nodes is linked to speaker nodes. So that's how you would make a virtual node version of the map. The second type of map that you would make would be using derived nodes. And so here what I would do is take my main system that I had before and just add my fills underneath the system. So now, instead of using virtual nodes, we connect our trisets to our original quad panner that we had in the room, and we just add supplemental derived nodes off of that. Now, the difference between the virtual node and the derived node can be seen here. If I have my panning locator on the top left, we'll notice that the matrix level within this derived node map, the matrix level of my main, my balcony left, and my under balcony fill are all exactly at unity gain. But if I crossfade into my virtual node fill, we'll notice that those exact same loudspeakers are getting a negative 4.8 value. And so what happened was we had the virtual node divide 100% of the level by 3. And it did the audio math for you, and it came up with a number of negative 4.8. So basically, this panning locator, as it moves, is doing the math for you and adjusting the loudspeakers and evenly weighting the audio. So it may be useful for some things, but for other fills, you might want it static and have it always say that anytime my main left gets a sound, it needs to come out at the same level of my fill system at the exact same level. So that's 2 ways to deal with fills. We'll go back to the keynote and hand it over to Bob.
Hello, thanks, Josh. Thanks, everybody, for showing up, and let's go to it. I'm going to take one very brief minute to review what we covered in the previous 2 weeks. I can't do it all, of course. That would be a big waste of everybody's time. But the key concepts that we go to is that we have a go zone that we create as a portion of the space. It's basically, we use this G factor, the go factor, which is 1/4 of the shortest side. And we design around that to get the proper spacing between speakers and the proper aim of speakers. We use the G factor, the go zone distance, to set lateral speaker spacing. So you can see this distance here is the same as that spacing there. These are also at a height of 1 G, somewhere between 1/2 and 1G is the height. At anything less than 1/2, you're going to not be able to get any kind of depth of coverage into the room. And anything higher than 1G, you're going to be perceived more as an overhead source than a lateral source. So that breaks the magic of our lateral surround simulation. And then we space the overheads with a minimum of 1G, and really like to shoot for 2Gs. And then you space them with the same kind of spacing as the height above the audience. In our example that we mostly use and I continue to use today, we have a 20 by 20 room, which leaves you with a G of 5 meters. So it was a 5 meter spacing of laterals. Depending on the density of your mains, it can be 5 meter spacing if it was 3 mains, and then you start to fill up that with more speakers. So you end up with a 1/2 G spacing with 5 mains. Then these are all at a 1G height. And then the overheads are at a 2G height and a 2G spacing. So that's the basic thing that we've been going with. You can scale that to a smaller venue. You can scale it to a larger venue. And as we saw, when you start to add distance, you start to rectangulate, you end up adding more. This in case we went from 4 laterals on the side to 5. And then as the room got longer, we got to 6, and it goes on from that. Now we're at 8. We're going to be done with PowerPoint. We are going to go to Map 3D. Really what I think I was going to hit on first is the under balcony. We're going to have a balcony start to creep into the space. I'm going to leave the space flat for the moment. So here's our familiar square shape that we've been working with. You would recognize we have all of the same players that have been with us all along. And there's our fronts, our rears, and our sides, okay? But now let's add in a balcony, okay? It's a 5 meter thing, it looks like. So it's taking up 1 square, okay? Well, what that means is that it resizes everything for us. These guys are now in a crappy position. I'm going to show you the problem that we have here is this balcony has just arrived. Now, what I'm showing on this picture, I've got a high and a medium and a low rear speaker just for fun to show you. And you can see the low is already underneath the balcony. The medium is basically right on the balcony, and the high is going to skim across the balcony. So what it's done is it's either forced us to either go into extra high, which we don't want to do for the hall overall, or we're going to have to split high and low. And of course, that's what we're going to end up doing, is we're going to end up splitting high and low. So what I've done now is I've taken a speaker underneath that's going to cover underneath. I've taken a speaker over the balcony that's going to cover there. And then I've got another speaker that's on the balcony front, and that's the speaker that's going to continue to be part of the fully granular system. So that's the key thing, is we're going to surrender full granularity to these back areas, and they're going to take an approach that is, you can see I'm not aimed at the center go zone anymore. These ones are aimed as a straight guy. So basically, I cover, I cover, I cover, I cover, and they go, and as an array overall, they will cover the balcony area. You can see that I'm too close for any one of these to cover this by itself. And as the goal of Spacemap Go is for each of these guys to cover the whole room or a large part of it by itself. You can see that's not at all going to happen here. No matter what angle I aim this thing at, it's never going to happen that you're going to get that experience. So if I go and I look at these overall as an array, I've essentially built a more of a cinema style approach. And 4 of these guys together will make a full coverage of the over balcony. So that's covered there. And the aiming of it is essentially to contain them so that that area is covered and it's not going to go and spill over into everywhere else. Now, looking at the remainder of the room, you can see what I've done is I've actually modified the go zone to exclude this 5 meters of balcony. So the go zone on this 25 by 20 meter room should have gone out to there. I'll show you the original go zone was right there. Okay. And that's the go zone of the room as a total. Well, this is now the go zone for the room that remains after we have surrendered the balcony. And so the laterals now are aimed at this go zone center, as is the new rears, which are the fully spatialized rears. So they're added through there. You'll notice, if your eyes are good, that the mains, however, are going through a different spot. Well, they're at the center of the old go zone, okay, which I will light up there. So they're centered through that. Why? Because from the mains point of view, these people are still in the room. They're looking at the whole room. So I don't want to go and cross the mains in too early and too hard and start to move these people into an off-axis situation. So the mains are still looking at the whole experience. But for the side and the rear lateral experience, well, these people are going to have to go and get their side and rear laterals from other performers. Who are the other performers? Well, those are the ones that Josh just described to you. So we have these local flat rear surround, and I have also a side surround, which you can notice here is a single guy, and I'm using not the traditional wide speaker that we are used to using in this application, but a 80-degree version. This happens to be the Ultra X22. So we're going to go ahead and keep that thing contained and make a side surround to try to get across the room. You'll also notice I can't get all the way across the room. Well, I've got the same trouble as I would have with the simple fact that I'm too low. So that's the story there. Now, of course, these people are going to still experience some of this action. They can still feel it sort of moving up toward them, but then this is going to be the primary player for them. So you've made a back room that is got less movement, but we have kept this area here fully operational. So that's the basic idea. Now let's look at the side view and think about this, because there's some other implications here. I normally use the highest position that I can. In this case, let's check who you are. You're at the medium position, 4.75. Why are you at the medium position? Well, let me just show you what you get if you go to the high position. And you can see there's a big continuity break between the high sides and the rear surrounds. They're stuck on the balcony. They have to physically attach to the balcony front. They don't have a choice of going up here. And I go to the medium side. Okay, I'm getting closer. If I go to the low side, then I'm right on the same mark. Well, so from a continuity of exact vertical location, the low side is the way to go. But I'm going to tell you, I'm going to fight that in practice and try to get to the medium side. So I'll show you why. I'm going to go to the low side position, go back to a predictable place.
So Bob, one important point while you're doing that I think is super important is that you're using the go zone for audience area to determine placement and coverage. This is not the immersive zone. This is not the zone where the only immersion will happen. Once again, the go zone is just used for spacing of placement and angle of speakers for each audience area. And in this case, with the balcony, we've basically got 3 audience areas. We've got the orchestra, we've got an upper balcony area, and we've got a lower balcony area. And so the frontal system is almost able to take care of most of this. And so using 2 separate go zones, you were able to outline and space the speakers that are in that zone properly. And we'll see that coverage is far beyond what it normally would be.
So the medium can cover how much of the room? Let's see. Okay, so it can cover still a good portion of the room. So just to illustrate, I'm going to bring this down to what I remember is the low setting, which is 3.5 meters, which is 2.5 meters above the. So there I am at about, I'm adjusting the aim angle. So it's about 6.5 degrees. And now I'm going to take that same guy, I'm going to predict him, and you're going to see a big shrinking of its custody. Boom. So I lost now a big portion of the room. If I just go back to this guy, you can see what that can do. The cost of going from medium to low is major. That's a big room. I can still brag about that. And the balcony guys, what are they doing? I want to at least be able to keep up with the Joneses there. We don't expect them to cover under the balcony because that would be impossible. So that's as good as they can do. So I at least want to do that or better. So that's why I'm going to go with the medium position on that. One of the little tricks, and I'm going to show you that on an example in a minute here, is that if there's under balcony delay speakers, if you had under balcony delays, those can also function as overheads. So you would bus those onto Spacemap Go, and when you wanted an overhead experience to happen under the balcony, you would bus things into that channel. So that brings overhead experience there, because the overheads, of course, as you can imagine, don't have a path to the under balcony area. It's not about the coverage angle, it's about blockage of path. So this is a smaller balcony. This is one of those balconies that just is basically one or maybe two rows deep. These are, of course, a big pain because we have to work with them and deal with them, and it only adds like 9 seats to the whole place. So basically, you're looking at the same kind of situation. I've got an over, I've got an under. I'm aiming the under at it lands at the go zone edge. So that's what's going on there. And then I've got this character here is along that wall. And I'll go back to the overhead view. And there's my slightly shrunken go zone. You can see the mains are back at the original center, and these guys are going around, are slightly shortened. So it's really only slightly shortened. And when we have a small area that's getting this quasi immersion, the flat back. So for the 25 seats that we added, we had to add like 10 speakers. So think about that, architects. No, they won't. But that's the basic story there. So as the balconies get deeper, the more we're going to have to push our go zone is going to shrink for the laterals, for the sides and the rears. And the difference between where the mains aim and where the sides and laterals aim will get larger as we go. Let's go to another project. Okay, so this is going to take these concepts and you're going to see it put together in a real theater that was not designed thinking about Spacemap Go. So this theater now is a 3-floor theater. So I'm going to give you a section view. And let's get all of the levels turned on. Okay. So we've got floor, then we have under balcony here, under balcony again, and the balcony is this funny arc shape. So it's got a long arm coming down, and then we've got an over balcony area there. So how are we going to approach this thing? It gets pretty interesting. So I'm going to go to the top, and you're going to use these kind of derived situations like Josh described. Now let's start with the mains. You can see there's 5 mains. There they are. Those are 5 real mains, and each of those can cover the whole room. You can divide up the music into parts. You can put vocals in the center. You can spread your drums across. You can spread your instruments across and really do some great musical panorama, because all of those are wide throw speakers. The last thing you want to do is put a signal in all 5 of those arrays. That would be a mucho bado idea. So now on the sides, you can only see one of my side surround levels. That is the upper level side surrounds, and those are going to cover the overall place. Can you do kind of a straight
Yep.
section view?
So these are the lower level.
So that lower level, it has the familiar go level spacing, but what you see is that we've got a slight rake in the audience. So I had to try to move those up as we went up. And then I got stuck by balconies. The middle balcony is not shown right now on your. So now then there's an upper level of surrounds. Those are the blue ones. Those are laterals that will move the immersion up into the upper level. Okay. The yellow side surrounds are focused down onto the first floor, and then the blue ones are focused onto the floor. The yellow ones also cover a little bit of the second floor, but the second floor you can see is completely underneath the balcony. So it's going to be in that derived immersion that Josh talked about. So now what you see is you can see, you can really get it now. There's a set of rear surrounds that are on the balcony front of the first floor. Those are the rear surrounds that are going to do the job. Those are on the balcony front. So those are covering the room overall. That's them there. They're placed along the balcony front, and on the balcony front of the second floor. And so they make now a full immersion on the first floor. So the first floor is a full Spacemap immersion. Then when you get to the third floor, you can see there's side surrounds, the blue ones coming up, but the rear surrounds are behind you on the back wall, and they're not going to be able to be a fully granular. They're going to just individually be able to make an array of flat back wall coverage. So basically, you're able to bring the side image forward, and then it's going to kind of become static as it reaches the rear. It's not like you have no spatiality. You have tons. You still have a fully spatial 5-array main system, and you have still the ability to move towards the front with the green upper laterals. But then on the back, the sound behind you, and if it's a severely far right or left side, you're going to be standing there. Same thing's going to happen deep under the balcony, and you can see what's going on there under the balcony is a whole set of little guys just to cover the under balcony area. They're not going to go out into the room at all. They're just going to cover there. So all the rears, all the back wall is divided into local coverage of a flat back wall. And then the only rear fully granular is the stuff that's on the balcony front back there at the first level. Yeah. Now for the overheads, and maybe let's turn off a bunch of the laterals right now so that you can just see the overheads. So that's the overheads. Here's what's going on there. So the two big boys that you see, two big greens, those are firing down onto the floor. So there they are. And you can go ahead and shoot one of those. Just go ahead and predict that while we're here. And that's going to cover the huge part of the floor because it's big and high. So we put a single powerful speaker in there that can cover pretty much the whole room there. Okay. And so you can spin the helicopter around up there. And of course, it won't get, the only place it won't get is upstairs, either under the balcony or over the balcony. That is a UPQ D3. So it's a 15 and a horn in that particular case. So then you can see a second speaker, a little guy there. Go ahead and shoot that one. He's going to just focus on upstairs on the third floor. Now, he can't go super high because there's this thing called a roof to stop the snow from getting in. So that roof limits my height. So I can only cover half the room. So it's back to the generic overhead. It's not going to do a lot of left-right movement because basically I just have enough to cover the room between those two. If you wanted to add a third one, you could do a little bit of central and outside movement. That's more money and really not that much bang, but that's the story there. Now, how do we get overhead sound underneath the balcony? Well, this is where this under balcony delay is going to come in. You can see there's a little delay speakers that their normal job is to be under balcony delays for like the voice and these things. Well, those will also, through the matrix, be able to receive Spacemap Go signal. It would be delayed on the delay matrix, a static delay to make it focus with what's coming down from the sky. But that's the basic idea, is that there's underbalks for the second floor and there's underbalks for the first floor. That's not it. That's the rear ones. The underbalks, that's an underbalk. There it is. Okay, yes. So those are the guys. They're facing and doing the normal coverage of that area. Now, of course, that's just going to be, again, a flat overhead. The helicopter will fly, but the helicopter will not do circles for you. It'll just go up. So that's a way we can use that resource, which we need to buy those speakers anyway to help with the vocal intelligibility, but we can use those with Spacemap Go. And it's not going to cost you 1 million channels either, because we're not doing 360s with that. You don't have to do a whole bunch of extra channels for that. Okay.
And Bob, I have space maps for this if we want to look at it.
Okay, let's do that. What is Sean Hines' question? Upstairs lateral speakers look like they cross through the go zone where there's no audience. That is a good point. Okay, so on the upstairs lateral, let's talk about the blue ones. Okay, those ones definitely are all aimed way deeper than the center of the go zone, and that's because upstairs there is no people, essentially. So they are aimed deep into the room, so that if I'm a person on the front of that balcony, that guy there is aimed at me, yes. There's no point in having it cross through the middle of the, up on the third floor level. These are just designed to cover the third floor level. So there's no use having them cover in areas where there's no humans, unless they were a rigger belayed down from the grid. I hope that answers. Okay, good.
So what I did using Spacemap Go and designing space maps was I took Bob's map file and I sort of broke the room up into a sort of traditional 5-1 sort of layout. In that we'll have a left, we'll have a center, and we'll have a right speaker, and then we'll have a rear left and a rear right, and then we can base manage with subs. And using virtual nodes, I connected all of the trisets to only the virtual nodes in this space map. And so what we can see is now, using this space map, if I move around, we can sort of see a 5.1 mix, and we can start seeing that different speaker nodes that are within this system are changing in level. This room has 2 balconies, and actually multi-balcony rooms are some of the hardest rooms to design space maps for. But this is where the flexibility of Spacemap really comes in. This is balcony 2. So here's second balcony's under balcony front. And then here's its side surround, dedicated lateral surround that Bob has designed. And then here are its 4 rear surrounds. And I just placed them in as speaker nodes. And then what I did was, using virtual nodes, I linked them together. And that allows for very easy control. So we can see that as I'm moving throughout the whole entire space map, if we imagined this area as just the balcony speakers for the second balcony, and we imagine this area down here as the balcony speakers for the underbalk or balcony 1, we can see that as I'm moving the space map around, that these laterals and under balcony speakers are moving and getting audio level as we move it around in the same system. And these other rows of speakers here are the upper level laterals. So if we look back, those would be our blue laterals that we saw within the space map. So this space map is easily controlling and making a sort of 5.1 mix of the entire room. So all I would do is simply load that on a channel, as I've done here for multi-balcony, and then I could have a sound effect play with a trajectory, and we could speed it up. And now we are literally moving the sound around throughout the whole entire room, and Spacemap is controlling this in a more broad strokes way. If I wanted more granular control, I could use a second space map. And this space map looks a little crazy because it's using derived nodes. And the first thing to note is that we know that it looks crazy, so we've made it a little easier for you. And all you would need to do is hide your derived nodes here. And if you go back into your application, we can then see that this space map looks a lot less crazy. And just to show you all of the speakers in the space, I'm going to increase the spread. And we can still see the same design principle. We have our normal level 1 orchestra area. Then we have level 3's supporting speakers. Then we have level 2's fills. And then we have level 1's under balcony fills. And here is that same space and same speaker count. But now, let me reduce my spread. And now we have a much more granular control of the room. So as I move around in a granular way across the front of the speakers to the back, you will notice that some of our under balcony fills start lighting up. And so just to show you the difference, I'm going to fade back in. I'm going to crossfade back in. Here's the 5.1 version. So a much broader sounding surround system. And then here is that same system under granular control. And so if I play my trajectory and crossfade between the two, I can actually now mix how wide I want the sound to be. And you can only get crazier from there. One thing that might be useful for a theatrical designer is touching on speakers with levels. Let's say I'm in a matinee, and in this matinee, I don't sell my upper balcony systems, and I'm just to have audience in the orchestra. Well, to save on acoustic energy going in the room and creating a nightmare, I built a space map that allows me to use the top of this space map to control the entire front and lower balcony, under balcony system. So as I move across here, and if I go into the surround, we can see that we have a little more granular control. And let's say for whatever reason, we were doing a show up in the balcony, we could do the same thing and move sound strictly in the balcony right here. To get even crazier, here's another space map, and this looks wild. I realize that. And so we'll show some virtual nodes. So let's say I have a sound effect that needs to start in the overheads and then go to the orchestra level and then go back to the level 3. So what this space map does is allows me to go from my overheads down to the orchestra really quickly, and I can move sound around the orchestra level, including under balconies. And then I can go to the edges and move that sound around granularly throughout the lower balcony. So as I go out, I start adding the upper balcony system. As I'm just in the orchestra level. And as I go up, I'm just in the overhead speakers. This is why Spacemap is so powerful, is because now the panner doesn't look like the room, but it allows me to, with a simple push of a finger, move a sound effect from the top to the bottom back to the top. This would be good for a tornado. So if I'm up in the air, my tornado's starting, and then I move my tornado into the room around the space, and I want to make sure my upper balcony hears it. So now my upper balcony is going to hear it, and you can start seeing how powerful this can be very quickly to control large chunks of multiple speakers within the room. And so that's that, and we'll continue on.
Speaking of tornadoes, looks like one has broken out here. Okay, so we're in an arena. We've gone to an 18 dB scale. We normally been seeing 12 dB, just red and blue. I've added another level because when you get to very large spaces, you're just going to need a little more vision. Okay, so this is, in this case, a quad surround that is bringing, it's an array of speakers, 8 leopards, I believe, in this case, or maybe 10. Oh, there it is. Yeah, 10 leopards. And it's covering a large part of the room from there. But let's just go back and get to know this room a little bit. Okay, so it's an arena. we can sort of visualize what arenas look like. This is not a, let me get rid of those speakers and just start with the traditional speaker arrays in an arena. Okay. Don't scream at me about my speaker array design. The mains, I didn't spend 5 minutes on them. So in terms of display angles, please, somebody's in the ceiling. But the idea is you got mains. Okay, there they are. So of course your normal mains is your left and right is your minimum in this world and some outfills, but let's say that we're going to go with 5 mains, so that would be your story, and they're all centered around the center of the arena, which is, and this is would be the go zone. This go zone is a little more complex because it's a hockey rink floor, and then it starts to rise up here. So I've had to break up the go zone with some flat area and some raised area, and so that's makes it a little more interesting. Now, what can you do with Spacemap Go? Let's get real. Let's do the cheapest, simplest thing we can do. Okay, this is the duo. Okay, I'm going to add 2, and this is nothing more than 2 speakers at the last place I can go to while rolling speakers on the floor. This is the end of this is the VOMs that are about to go up. And we all know these places in any kind of hockey arena. So that's the last place where I can just drop a motor down and then raise that speaker up without anybody dragging things off of the floor. So there they go. That's one thing you can do. What are you going to do there? You're going to create a sound experience mostly for front of house, for the mixed position, and the area in the center is going to get some sort of surround sound experience. I don't know how you're going to sell that, but it's, of course, a bit surprising in this world of how many things get sold of, well, we just made it sound better at the mixed position. So it's not like it's never happened before in our industry. So let's expand that a bit. We'll go to 4 additional sources. Well, it's those 2 and 2 more. So now the people with the really expensive seats are going to get a more of a full 360-degree panning effect. You certainly can't do a whole show like that, but you can maybe do some whiz bangy. Well, there's no reason to stop at 4. I can do 5. That's a 5-shot version of that. We can do a nano, which is 9 version of that. And now I've gone and I've broken out and I've expanded it to where I'm going through the elevators and I'm rolling it out the VOMs on the first level of elevation where everybody walks around. So now I'm going to hang from those spots. Now you can see I've now got a much larger part of the arena is inside of the game. It's still by no means the whole arena. You want to play for the whole arena? I can do that. It's just going to cost you money. It's not about Spacemap Go needing these things. Anybody, if you want to have everybody get into the game, well, it's just going to cost you money. You got to have more locations. So here I've now put them out there, and this still isn't even all the way out. All the way out means you got to go all the way out. And in this case, the ceiling was, only about 3 meters over these people's heads. So let's get realistic. There's no way in the world you're going to go there and have an experience. I'm sorry. But at this location, starting about here, you were able to start to project over enough heads to get a decent experience for a large part of the room. I'll just go ahead and shoot one of these. I don't remember.
With long distance like this and the speed of sound, this might be a little weird for the drummer that's sitting on stage if they hear a slapback in an arena. So obviously when a mix engineer would be doing something like this, they would be mixing in the rear surrounds, things like reverb or things that don't have tempo, that aren't, staccato or to create slapbacks. Pads, strings, stuff like that is very useful content for that.
Right. It can't be staccato. And think about this. If I'm listening to this speaker and this one, they are 300 milliseconds apart. Somebody's going to notice that.
Absolutely.
Just like you can't play or beat the physics. And while this is going, you'll notice that I didn't spread these guys over the full go zone, because you spread the mains that far, a couple of things happen. One, they've already starting to climb up the stands. That's not real. So
Yeah.
I've kept them on the flat part of the arena and kept them to a place where they can reasonably hold together. So they're actually a quarter G apart instead of a half G. Now, so by here, this corner was trouble, but you can see at this location, I was able to cover a big part of the room. So that's pretty cool. So you can actually get some pretty cool stuff done. But those speakers had to be brought up. That's a long way to
Yeah.
go. Hey, how bad do you want it? The Galaxy is cheap. Uh,
Yeah.
that's
Yeah.
the least of your worries. Okay, but you've got to physically get the stuff there. There's practical considerations and all these things. We've seen, delay towers for stadium level, for example. And we saw with the Grateful Dead's shows, they would put surround coming back on the back of the delay towers. So when it went to the Space Jam, they start bringing in the surround. So if you're outside of that, it just sounds like the sound gets more diffuse and sort of spread. But inside of that area that visualize the stadium, inside of the football field where the delay towers were 1, 2, 3, 4, 3 delay towers, you can get a lot of immersion going on in that. Of course, it's still hundreds of milliseconds out of time. So if you were attempting to do something that was tight and on tempo, that's not a thing. The thing to always remember is if you ever analyze the sound of a marching band, you know what that means when there are 300 milliseconds apart. A unrealistic recording of a marching band, it's one that sounds tight. It's never going to happen in
Yeah.
reality.
The cool thing is, if this was an EDM show and it was just playback, you could do some fun things with it as long as the DJ, was being slammed with his Texas headphones. So, yeah, there's tons of options. Obviously, a production manager wouldn't do something like that. So, let's talk a little bit about practicality. One of the things that doesn't get accounted for in immersive systems, and recently, and now that everyone's making an immersive system, is the cost of processing meets the cost of the amplifier, meets the cost of the cabling, meets the cost of the production to get things up. What's cool about Spacemap Go is you've already done designs where you've had a loudspeaker inventory that's existing. So can you talk about when you get a design and bringing in practicality into this? Let's just talk about that for a second.
The guidelines that I go by for that Go spacing and these things, there's a couple of premises that's based on. It's based on that you are going to have the widest speaker available. So, I build everything around our X20s and X40s, which have the 110 degrees of horizontal. And that makes a great super wide shape so that it covers a lot of the room. But the thing that you're looking at is if you analyze this in immersion capability, you can look at this and go, okay, how much immersion am I going to have? Well, as I cross the go zone line, I'm going to make this into 1 dB per color. So we'll get a little more detail. So there is 0, 1, 2, 3, 4, 5, 6. You get the idea. So if you look at where the next speaker is aimed, it's still effectively, it's crossing the line is still in the 0 range. By the time this one crosses the line, it's 1, 2 dB down. Now, if you change this speaker to a more narrow speaker, if that was what was in your inventory, you can still keep this spacing. But what's going to happen is that as you cross this line, this one's going to be maybe 4 dB down, and this one might be 6 dB down. So essentially, you've just turned the blending factor down. If I were to have to cut my budget and I could only have 2/3 of the speakers, you get rid of this speaker and you get rid of this speaker. Do I still get immersion? Yes, because this is coming in at 2 dB down. When I turn this guy on, it's not like the people over here don't hear that speaker. It's about 1.5 dB down. So you can see that what it is a case of there's less of our blending. So what I've done is made it so that everybody is inside of at least a 3 dB kind of blend is the hope. And you take a location like here, if everybody's at this orange, and so that even somebody like this is coming in. By the time you're in the middle of the room, everybody is in it. You could have a super narrow speaker. By the time you're in the middle of the room, everybody's there. Okay, they're all going to be in that same color. The question is how far out it goes. And you can think of the wider the speaker and the denser spacing, the more it goes from this and keeps getting bigger and keeps getting bigger and keeps getting bigger. So if you have to cut down speakers, you cut down speakers, and that's just, I get less of the good stuff.
And as the mix engineer, as the artist, one thing to consider is this idea of granular immersive mixing, to where if I move my sound around, it's always going to go to every individual element, versus more broader abstract mixing, to where you can control the walls of speakers. And when you have to cut speakers, you can adjust the space map accordingly. And just to show that real quick, here we have that same arena setup that you were showing, Bob. Here is the space map with that 5 frontal system. And as you said, the production manager graciously allowed us to have a left and a right rear surround, so that the front of house engineer and some of the orchestra, the pit level, got a little more immersive experience. So here's the Galaxy. And if we look at this, this is not that many outputs. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outputs. If you're running AVB, that's a Galaxy 408. So you can use this Galaxy 408 at front of house and use AVB from your console into the Galaxy. You can have a 32-channel immersive mixer and use this space map with 2 extra hangs and use the tool Spacemap Go to mix an immersive show.
To put perspective, the Galaxy 408 is going to cost you about as much as a UPA.
Yeah, which is, when you're doing an arena size show, or you could also rent it. Chances are you're renting it for tour.
It's nothing.
So now you're using a Galaxy to have immersive audio. So what if we can add 4 speakers? Well, here's a space map to where we can now have a frontal mixer and do the same thing that's really hot in the industry right now. And we can put our instruments and mix frontal, but then we can add our 4 speakers. And now we have a space map that now we're in our quad surrounds, and we have front and quad. And so there's that space map. I'm going to hop over to another channel. Let's say, as you said, we could add 5. Well, here's a different space map. Same frontal loudspeaker system, and now we have 5 in the surround. And if I crossfade over to another map I designed that's got 9 in it, now we have 9 speakers and our frontal system. Our production manager is starting to hate our load-in times, but we might be able to get away with this at a corporate event like or a esports event in the arena. And so now I'm using the same Galaxy. I've got a little more outputs, but I'm still under 16. 1, 2, 3, 14, 15, 16. Yeah. So I think I'm still under 16, 17. We've reached the point where we would need 2 Galaxy 408s to do this. At my front of house console, I could have 2 Galaxy 408s. And then as we expand upon that concept, like you showed, now we have the arena where we have this frontal mixing system. We have an overhead system. And we have the surrounds, and the whole entire arena is involved. And we can continue that on and add more and more things. But the tool and the mixer and the Spacemap Go system is here, and we could add it across channels and do a lot of things with it. So this idea, it's all about you as the mix engineer. And we've tried to create a tool that allows you to work with the tools that you have and work with the outputs and the speakers that you have. We're not saying you need 5 speakers in front. We're not saying you need 12 speakers in back. What we're saying is take your inventory and think about the fundamentals of systems design. Pick the right speaker, put it in the right place. As we've seen, if you put it in the right place, you can really get most of the coverage area for surround done right, and then point it in the right direction. And so the go zone and these steps that Bob has come up with are really just guidelines to help you do those fundamental three things of any system design. Pick the right speaker, put it in the right place, and point it in the right direction. And the Spacemap Go tool, this free tool for mixing, is just that. It's an immersive mixing platform for you to use based off of the outputs that you have and the inputs that you want to put in it. So we've sort of given you a sandbox of a mixing platform to use for live as well as theatrical environments.
I like to look at it this way. It's like we're talking about in the lateral domain, it's a 360 degrees. And you can slice that up however you want. If you got 360-degree speakers, probably 1 degrees is probably the logical way to go. But if you only got 4, well, then it's going to be 90. But you can see that it's going to be a lot chunkier of an experience. You're asking a lot more of your brain to be forgiving when it's going to make a jump over a 90-degree span. That's a big leap. We don't boss you around. We'll make 90-degree leaps if we need to. We'll make 1-degree leaps if we need to.
I want to hit home these fundamentals. And we've been doing a couple big, large-scale systems for these giant multi-balcony speaker systems. This is an 8,000 seat auditorium, or over 8,000 seats, I believe. This is one of those very large-scale, wide fan-shaped rooms. And for side surrounds, in a room this size, it's very difficult to get that throw from here to this speaker. And so what we ended up doing for this design is actually using a Leo for a side hang. And I thought it was crazy at first. And then I looked at it in Map. This was designed by David Vincent with the help of Bob as well. And look at what a single Leo is doing to cover the whole entire under balcony for a side surround. It's really quite amazing. Now, of course, you're going to have to deal with propagation delay and timing and stuff like that. But this is the definition of picking the right speaker for a room.
If you look at the presentation last week where we discussed the symmetry and asymmetry of speakers, when you have that kind of hit, you want a highly asymmetric speaker, which is the Leo is 5 degrees by 70 degrees. It's pretty asymmetric.
Yep, and it's a long throw speaker to tuck in. And it's great for when you have these wide fan-shaped rooms. You would never think practically, like, why would I ever have a Leo in there? But in this case, it was what was needed for the room. You can look from a top plan view. You can sort of see that each section of underbalk gets a quad front and rear surround for all the underbalks. And so the way we made the space map would be to mix down what's happening here in the orchestra level into a quad scenario for the frontal system, as well as a side surround as well. So we'd have the side surrounds if we needed to. Oh, we have one question. Do I understand right that you would prefer speakers with a small coverage for systems in small rooms?
No. You can have a smaller power level of speaker, but always want the wide speakers. In all applications for laterals, you want to have an asymmetric speaker, one that's wider in the horizontal than it is in the vertical. And then for overheads, the certain shapes of rooms are more favorable to a symmetric type of application, like a 110 by 110 or 80 by 80. But oh no, please, I like wide, because immersion is all about overlap.
Yep, it's the exact opposite of everything you've been doing for the past 30 years.
It's turned over to the dark side, yes.
Yes, yeah. Instead of lining up your negative 6 dB points and having nice separate but equal power, now we have equal but equal on top of each other.
Instead of always striving for the isolation zone, I'm now heading like, give me combing.
Okay, we have a follow-up question from Dominic. What kind of measurements would you do when setting up an immersive sound system?
There's timing issues and relative level. But one of the key things for me when I'm tuning one is that the app has an assumption of equal sensitivity. So that if you move from one of Josh's little green dots to another green dot, they can't be 20 dB apart. The assumption of the math behind Spacemap is that if you put in 1 volt into both of those speakers, that they will give you an equivalent output in the room. Now, if one is farther away, that 1 volt might need to be to a bigger speaker that's 6 dB louder to throw the same, to throw twice as far to get to the same SPL. So what I'm going to do is I'm going to work around this Spacemap Go box to get things to come in at equal level, to enter into the zone at around the equal level, and things that enter into the zone will also enter in around the same time.
This is a room that's designed for even coverage and even immersive coverage across the area. And so obviously there are time things that you'll have to deal with in EQ. So as with any sound system, you're going to make an on-ax measurement of your mains and make sure that the line arrays are covering the way they need to be across the whole entire space, and get your curve that you want for your audio and match that to every other speaker in the room for tonality. And then tonality and timing are always a thing. And with underbalk systems, you sort of look at the job that the underbalks are going to be doing. So this underbalk is going to have a couple purposes. As we said, it's going to be a normal, standard, everyday underbalcony fill for the mains, but it's also can be used for an overhead. So within the Galaxy delay matrix, depending on what I'm doing, I could add a delay matrix delay time to bring this guy back to have a relationship with the overheads. Another thing with rear surrounds that's very typical is delay and relay systems. So in this system, Bob has these main surrounds, rear surrounds for the orchestra level. Then we also have lower surrounds and 3 levels of rear surrounds, basically. And so you would probably time these guys on this orchestra lip and delay them back to the underbalks. Yeah, so playing with delay is fun. And also remember, we as humans with our FFT analyzers we have a very good about 1 degree of listening, especially in our horizontal plane. But when you get behind, we're a little more forgiving, and we're a lot more forgiving in the vertical plane. So we can sort of, manipulate that. Theatrical designers do this all the time in spaces.
So to answer the question here, dealing with the rake seating, the preference for sure is to have the laterals rise with the rake. If they stay static, they're essentially changing their relative angular relationship, and they're changing their depth of throw. So you can see the blue speakers in this one that are the 3rd floor laterals, and they are rising as the rake goes up. The 1st floor laterals aren't rising. See, they're not rising, but that's only because they ran out of room and got bumped into by the balcony there. And so as a result, that 4th one is getting pretty crushed. It definitely has less throw than the 1st one of those side surrounds. Whereas upstairs, they're keeping a pretty constant distance. So yeah, for sure. And when you get to rear laterals on a raked room, they've got to get high. Otherwise, they'll never make it down the slope.
Yeah, I think that's super important. Height, I think you'll find as you're designing immersive systems, height is your best friend in a lot of ways. You want to be under that 45 degrees for laterals for sure. But as you go up, the more people are in the immersive coverage area. Let's see. Would you prefer multi-mics, I guess, east, west, north, south, from center to quickly calibrate the audio?
Calibrating the main system that's a multi-mic experience because you're looking for uniform coverage in the traditional sense. That's just your regular old correlated data, and each one of those is going to get run and turned into a single system. Then from the surrounds as they go, you're going to put a mic upstairs on each level is really where they're going to go. It's not about averaging, but there's certainly merit to putting a mic at the front of the go zone and at the center of the go zone and at the far end of the coverage if you want to be able to see what your front to back differential is over the space. But if you're researching, that's all great. But if you're just tuning and getting the hell out of there, then you're basically going to run 1 mic along the edge of the go zone and run that step by step around 360 degrees, locking in each part of the clock hour by hour as you go around the circle.
And especially in rooms like this, where you have speakers against walls, you're going to have a boundary load. And that boundary load, depending on where that speaker is, will be different. So you're going to have low mid buildup and need to EQ things a little bit differently. One thing that I like to take an extra step for, I like when I'm mixing in a room like this and I have this ability, is I like to make space maps to where I have all the wall speakers on. So I have a north, south, east, west space map. That way, if I put a sound in the right wall, it comes out of every single speaker. And the space map will level match it. But sometimes, obviously, if you're going from a bigger to the small speaker, there's a level adjustment that you need to make. And so I like sort of gaining my walls together and making sure that my left wall, my right wall, my rear wall, and my front wall are all in the same SPL level as well. I want to thank you, Bob, for doing all the hard work and the legwork on this series of roundtables. It's been great having you, as well as my partners, Jose and Yanina, fielding questions. All right, everyone. I'll see you later. Thanks, Bob.
Thank you.
Bye.